My name is Remy Pangle. I am the Director and Education Manager at the Center for the Advancement of Sustainable Energy here at JMU. Today I'm going to give you a tour of our small wind training and testing facility. This is a hybrid facility featuring a 10 kilowatt wind turbine as well as a small array of solar panels. We use this facility for outreach and education, bringing classes in to tour the facility. Community groups learn more about what it means to have renewable energy at their home. And we can also make this facility open for research opportunities for JMU students. We have a dashboard on our website that can give you an overview of how much energy we're generating, as well as an opportunity to download the data from all of our instrumentation. We're going to be touring you through all the components of this facility, the solar panels, the wind turbine, as well as the building where we are controlling the power. So next, you'll get to learn about the wind turbine. Okay, so we're here at our wind turbine. This is a small wind turbine. It's only 120 feet tall and has a rated capacity of 7,500 watts. So that's at like maximum wind speeds of somewhere around 30 miles an hour. The cut-in speed is around 8 miles an hour, and at very high speeds it will actually shut down to protect the generator from any damage. The turbine has 3 blades and it has a tail. The tail is used to keep it out of the wind when the winds get too high. It's called furling. So now we're going to talk a little bit more about the instrumentation and the tower here. Okay, so you're looking right now up the tower. So again, this is a 120-foot tower. As you can see, we've got instrumentation on booms at various angles and at various heights up the tower, and then the turbine at the top. So the reason that we have so much instrumentation on this tower is so that we can better understand the wind characteristics at this location. So having an anemometer and a wind vane at each height allows us to tell what happens as you go higher, how the wind changes. So as you can see right now, the bottom anemometer is spinning a little, the one in the middle isn't spinning at all, and the one at the very top is spinning very fast. What you can't see right now is there's a building in the way of the wind, so that's probably why the second anemometer isn't moving so much. So it's important to know about your wind. And the anemometers at 2 different angles allow us to take into consideration something called tower shading. So if the wind is coming from the direction in front of the tower, the anemometer behind the tower may not spin at the same speed as the one that doesn't have the tower interfering with it. And this allows us to quality control our data. So the other thing is, I've mentioned an anemometer and a wind vane. The anemometer is the one that spins and it tells us the speed of the wind. But the wind vane is the one that looks like a tail or a paddle, and it is going to tell us the direction of the wind. And again, you can see right now it's a pretty windy day, and our wind is shifting a little, maybe a little bit of turbulence because of the building. But that's important data to have to understand the impact on your turbine as well. Our facility also features a Weatherbug system. You can see the anemometer and wind vane at the top. There's also a rain gauge, there's a barometer, a thermometer, a hygrometer, you name it. All the weather data is being collected here. Also helps us to characterize our site. And if you ever need to know how the weather is on campus, you can find us on the Weatherbug app. Okay, here we are at our solar array here at the Small Wind Training and Testing Facility. This is a small solar array that's a rack of 15 solar panels, and each solar panel is made up of small solar cells. These solar panels are what we call thin film technology, and they only generate about 50 watts apiece. So again, 50 watts, 750 watts total for this 15 panel array compared to the 7,500 watts from the wind turbine. So a small array and it's producing electricity from the sun. So right now we have a lovely cloud that just went by, but when the sun pops out, these guys are going to grab those energy from the sun and use it to generate electrons, and that electricity flows into our control building. You'll notice that the solar panels are facing a particular direction. That was on purpose. We like to face our solar panels south because our sun is always over the equator, which is south of us here in Virginia. We also have them at a particular angle, which again was not done randomly. It's very specific to the degree north we are in latitude. So our solar panels tend to be at cleaning. In places where you have a flatter solar panel and it's dry and desert-like, cleaning your solar panels is definitely something we need to talk about. But here in Virginia, at this high angle and in a place where we get lots of rain, cleaning is not something we have to consider. Okay, we're now in the control building here at the Small Wind Training and Testing Facility. And this is where all the electricity comes to be processed, stored, and used. So our solar power is going to come in, and the first thing it does is it comes to the outback system, which is an inverter and a voltage controller. So solar produces DC power, which is what we're going to store in the batteries. So there's no inverting necessary, but definitely charge control happens. Right now the system is telling me that there's a big cloud outside and we're not getting very much solar energy at all. But whatever power is being produced is going to come through here, the DC combiner box, and then get stored in our batteries. The wind power is AC power, so it comes into this system here, which again is an inverter and a voltage control system. It needs to be converted to DC to be charged, to be stored in the batteries, and the voltage has to be brought down so that it can flow into the batteries. The battery system here is a 48 volt system. We've got large deep cycle batteries like you might see in a golf cart. We've got 8 in series connected to another 8 in series, but those are connected in parallel. So we've got quite a nice storage system here. Now, what happens if we need to use that power? If we need to use the power here in the building, our buildings use AC power, but we're storing it in DC. So it needs to go through quite a conversion in order to get to our outlets to be usable to run our computers and our lights. So the first thing that happens is it gets pulled through these inverters. And these inverters are now going to take the DC power of the batteries and change it into AC power to be used in our outlets. But this power is at around 48 to 50 volts, and we need it to be at about 110 to be usable in our outlets. So the next thing that happens, it goes over here, which you don't need to see, but there's a box on the floor called a transformer, and that transformer is going to bump up or step up our voltage to 110, and then those electrons get stored kind of in our control panel until somebody flips the switch and those electrons start to get used. So we've got high efficiency LED lighting in here. We've got a ventilation system as well as an AC HVAC system, and then we have our computers and all the monitoring that's in here. So south-facing windows, it's a highly efficient building, still uses electricity. Now, the next question might be, what happens if the batteries are full and we're producing more electricity than we need? Where does the electricity go? And that is a great question. So the electricity that we produce here in the Small Wind Training and Testing Facility, from the wind and the solar, is used by this building. There's some outdoor lighting as well. And if we don't need the power, we're able to give that power to the JMU grid. So JMU can use the power if we don't need it. So batteries are full, we're not using all that electricity, JMU can use it. Now, on the opposite side, if for some reason there's no wind, there's no sun, our batteries are being maintained so we can't use our battery power, we can pull electricity from the JMU grid to use to power things that we need in here. So it's a very flexible system. And if you were to have wind and solar at your home, you wouldn't have all of this in your home. Usually you probably would have either wind or solar, number one. And number two, you probably wouldn't be set up to both store energy in a grid-tied system or an off-grid system and use electricity from the grid in a grid-tied system. You'd probably pick one or the other. So this is definitely an educational demonstration facility. We've got everything in here, way more than you would possibly need at your home. Another question we hear a lot of is, how much electricity does this produce? Is this enough to power a home? And that is a really good question. So I'll give you an answer. 750 watts of solar and 7,500 watts of wind at maximum optimal situation is more than enough electricity for an average home. So if these are performing, then definitely more than enough to power your home. Now, on a day like today, it's a little bit sunny out. We're not actually seeing a lot of solar power right now, maybe a couple of 100 watts, 300 maybe. Our wind turbine is chugging along. I don't know if you can hear that buzzing, but that's this step-down transformer that's helping bring the voltage to the right situation. But we are seeing wind speeds of well over the cut-in speed, so almost 9 to 10 miles an hour meters per second, which on our power grid or power curve indicates to us that we are producing somewhere in the 2,000 to 2,500 watts. So right now, at this instant, we're producing almost 3,000 watts. These lights maybe use 15 watts. The computer maybe uses a couple 100 watts. We don't really have the AC or heat on. So right now, JMU is getting a lot of our electricity. So at this instant. The last thing that I will show you is our dashboard and our website. So if you want to learn more about our facility, you can go to jmu.edu/CASE, that stands for Center for the Advancement of Sustainable Energy, and you can click on our dashboard and see the current electricity generation at any point. You can also find our Weatherbug data on the website, and we hope that you enjoyed this, and we'll be in touch at casejmu@gmail.com with any questions or any other comments that you have.